In this video, I want to talk a little bit about the connection between the rectangular coordinate system and the polar coordinate system. Now, when I say the connection between the two, this connection, after we discover it, is going to help us be able to jump back and forth between these two worlds, between the polar world and the rectangular world. And that's going to be useful to us because sometimes it's easier to work in the polar world and sometimes it's easier to work in the rectangular world. So we need to know how to bounce back and forth between those two different worlds. So let's take a look at this figure over here on the left. Here we just have an XY plane. And you can see that we have a point labeled in that XY plane. We have the point P, which is X comma Y. And we get that by starting at the origin, going X units to the right, and then Y units up, and that gets us the point X comma Y in the rectangular coordinate system. But we can also get that same point in the polar coordinate system using a theta and an r. This same point can be called r theta if we rotate in the counterclockwise direction, theta, and then move a distance of r from the pole or from the origin to that point P. Now, because we've overlaid the polar world with the rectangular world, it makes seeing the relationship between the two a little easier. Notice that if we were to look here at theta, we could say that cosine of theta is equal to the adjacent side over the hypotenuse. So that would be x over r. Now we could solve that for x by multiplying both sides by r, and we would have r cosine of theta equals x. So if you give me a point in polar coordinates and I want to change that to a point in rectangular coordinates, here's the connection. To get the x coordinate, all I have to do is multiply the r given to me by cosine of the theta given to me. So you give me an r and a theta, then I can get x by multiplying r times the cosine of theta. And then likewise, we can do the same thing to find the y coordinate of that point in the rectangular coordinate system. We could see that sine of theta is equal to opposite over hypotenuse. So sine of theta would be equal to y over r. Solve that for y, and we get r sine of theta equals y. So you give me any point in the polar system, r comma theta, I can use that r and that theta to find the x and y coordinate of that point in the rectangular coordinate plane, using x equals r cosine theta and y is equal to r sine theta. But now let's suppose that you give me a point in rectangular space, an x comma y, and I want to change that to the same point in polar coordinates. I want to change the x comma y to an r comma theta. Here's how we do it. From our illustration here, we notice that x squared plus y squared has to be equal to r squared by the Pythagorean theorem. Well, if you give me an x, all I have to do is square it and add that to the y squared, and that gives me r squared. So now I have a way that if I'm given an x and a y to solve for r. And I just use the Pythagorean theorem. R squared equals x squared plus y squared. The only other thing that we would need to find would be theta. And to find theta, we can just use the trig ratio for tangent, because we know that the tangent of theta is equal to the opposite over the adjacent side. So you give me an x and a y, then I can say tangent of theta is equal to y over x. And I can use that information to solve for theta. So here's the gist of it. If we're given a point in the polar world and we want to convert that to a point in the rectangular world, we use x equals r cosine theta and y equals r sine theta. If we're given a point in the rectangular coordinate system and we want to change that to a point in the polar coordinate system, we can use r squared equals x squared plus y squared and tangent of theta equals y over x.